everyone, myself Netrahati, studying at Sri Venkateshwara College of Engineering. Today's my topic is application of inverse transform by the method of completing the square. The course name is Mathematics for Triple E stream. See the application of inverse transform by the method of completing the square. Introduction to inverse transform by completing the square. Inverse transform by completing the square is a method used to find the inverse Laplace transform of a function by completing the square in the denominator of the Laplace transform. This method is particularly useful when dealing with functions that involve quadratic terms in the denominator. It helps simplify the process of finding the inverse Laplace transform in cases where partial fraction decomposition is not straightforward. Completing the square technique involves rewriting a quadratic expression in the form x plus a whole square plus b, where a and b are constants. This technique is commonly used in algebra to solve quadratic equations and simplify expressions. In Laplace transforms, completing the square can help in simplifying integrals and finding the inverse transform. Steps for applying completing the square in inverse transform. To applying completing the square in inverse transform, start by expressing the denominator of the Laplace transform in the form x plus a whole square plus b. Identify the constants a and b by comparing the quadratic expressions with the standard form of x plus a whole square plus b. Use the method of partial fraction decomposition to separate the terms and find the inverse Laplace transform. Example 1. Inverse transform using completing the square. Consider the Laplace transform f of s is equals to 1 by s square plus 2s plus 2. Rewrite the denominator as s plus 1 whole square plus 1 to apply completing the square. Use partial fraction decomposition to find the inverse Laplace transform. Example 2. Application in control system. In control system analytics, completing the square can be useful to find the inverse Laplace transform of transfer functions. This method helps in analyzing the stability and response of control systems. By simplifying complex functions, completing the square aids in designing and optimizing control systems. Signals processing applications. Completing the square is also applied in signal processing to find the inverse Laplace transform of signals. It plays a crucial role in analyzing and processing signals in communication systems. By using completing the square, engineers can design filters and systems for signal processing applications. Advantages of using completing the square in inverse transforms. Completing the squares offers a systematic approach to finding inverse Laplace transform of functions with quadratic denominators. It simplifies complex integrals and calculations involved in Laplace transform computations. This method provides a structured way to handle functions that are difficult to composite using other techniques. Limitations and challenges. Completing the square may not always be applicable to all inverse transform problems. It requires a good understanding and algorithms, algebraic manipulations, and ability to identify suitable quadratic forms. In some cases, completing the square may lead to complex expressions that are challenging to simplify further. Comparison with other inverse transform techniques. Completing the square is one of the methods used to find inverse Laplace transforms along with partial fraction decomposition and convolution. Each technique has its advantages and limitations, and the choice of method depends on the complexity of the function. Complexity: the square is particularly useful for functions with quadratic terms in the denominator. Conclusion: inverse transform by completing the square is a valuable method for finding the inverse Laplace transform of functions with quadratic denominators. This technique simplifies the process of inverse transform computations and is commonly used in control systems, signal processing, and other engineering applications. Understanding and applying completing the square can enhance the analysis and design of systems in various fields of engineering and mathematics. Thank you.